is mainly on the with regard to air conditioning system. As you know, in a air conditioning system, the room is fully enclosed, and because you want to make sure a certain temperature is reached inside the room. Most of the time, in Sri Lankan context, it is a lower temperature than the outside temperature. So then there is some amount of CO2 which is gathered inside the room, and the CO2 levels inside the room increases. So when the CO2 levels, because of the human presence, otherwise it's not a problem. So fresh air supply is not required if only machines are there, because there is no breathing elements. But if human presence is there, then there is certain amount of CO2 that is generated, and the CO2 level goes up, and maybe the oxygen level also goes down, because it is a fully sealed space, like a fridge. So then in that case, there could be certain other issues which are arising, which you need to cater to. You call it building syndrome in technical terms, where you feel dizzy, sleepy, not active. ප්‍රශ්න ටිකක් එනවා when the CO2 level reaches to a certain extent. CO2 levels very high is also a problem. But this is with regard to inactiveness. So in that case, you are feeding in certain amount of fresh air supply into the room, and maybe exhausting. So the second point is exhausting. So to balance the space, you have to actually exhaust. Otherwise, the room will, like a balloon, the pressure will increase. Then that is also will be uncomfortable. So exhaust systems can be also like toilet exhaust systems, where you have to remove the odor, where it is certain odor is generated due to maybe hydrogen sulfide or whatever the pollutants. So you need to take off, which you have exhaust to remove the odor. So you run separate exhaust systems where like public toilets, where the usage is high, and where you cannot control, and where sometimes they are not exposed to outside. They are actually in a very inner premises, that there is no breathing space for the room. Then car park ventilation is mainly in enclosed car parks. Imagine if you're having a basement car park or something like that, and an enclosed car park where there is no breathing, and there is no enough ventilation. Then the risk is there could be carbon monoxide that is being generated, and that you need to take it out. And carbon monoxide is very critical. You can't entertain even, I think 10,000 ppm is the limit. So it is in a very critical stage where even death could happen if the carbon monoxide level goes up. This is similar to the barbecue machine having inside the room and sleeping inside. In the morning, you are comfortably dead. So carbon monoxide is very dangerous. So you have to ensure that carbon monoxide is taken out from premises to ensure human safety, actually. Then stairway pressurization is mainly in case of fire, where you don't, in a high-rise building, where you don't use the elevator, where you're supposed to take the staircase, which will be another fully enclosed space apart from the office area, not attached to the office area, so that in case if one office floor or one floor is on fire, the staircase is not affected. So it is totally out of the space. So to ensure that there is enough ventilation, and also the fire is not spread into the staircase, you actually pressurize the staircase. Make a pressurized කිව්වම ලොකුවට බැලුම බන්නේ. It's in millibar or millimeters of water. So you don't pressurize it much, but you pressurize it to a certain extent that the fire is not spread into the staircase, and people from the top floors are comfortably able to come down the staircase. So those are the key ventilation systems that we use. We will get on with. So basically, in residential use, we are basically looking at ceiling fans and other types of fans. So fans also you get quite a number of different types. Relatively, ceiling fans are higher in wattage. It's about 75 watt roughly in the range of. But some of the KDK fans they claim to be 56 watt. And if you take the other types of fans, ceiling fans and as the pedestal fans and table fans and wall mounted fans, they are relatively less in wattage, 45 watt and higher in speed. But ceiling fans are generally lower in speed and lower in speed but higher in wattage. RPM is low. So the key point is ceiling fans is basically used for higher coverage, uh, not a small area, roughly about 20 feet by 20 feet or 6 meter space one ceiling fan can cover. So the purpose is a ceiling fan is trying to move the airspace and ensure that the uh, air circulation level is increased in that space and that the people are comfortable. It is not blowing air as such, so that's why the blades are a bit flat. And whereas pedestal fans is actually absorbing air from the back and pushing it. So if pedestal fans, if the behind the pedestal fan, if you don't have enough space or if you block it, then there is very less amount of air that you actually getting out of the pedestal fan. So looking at energy efficiency, key is for to ensure speed control of these uh, fans, because good old days we had this transformer type of regulators where it's a transformer controlled modulated, but whatever the speed you put, the consumption is the same. But now you have very high-end like electronic type. You can see the weight is also very less in the present regulators. So they have a kind of a capacitor control. So lower the speed, definitely lower the power consumption. So speed control is one key. So you ensure that you run it only as per the requirement. Then height of installation. So if it is a very high level that you are installing the ceiling fan, then no point. So best is if your roof level is high, ideally you bring it down so that you circulate only the space below the ceiling fan. Very low is also a problem because it won't be able to circulate a lot of the uh, air volume. So it has to be at a certain height and uh, not too low and not too high. So key thing is on these blades, you have to ensure regular cleaning because there is dust deposited. You will see a lot of fans with dust, and in my place is also we are having a lot of problem with corrosion by the sea because uh, if the blades are metal blades, then they tend to corrode. So if the blades are not sharp enough, if the thickness has increased, then the resistance to air is high, so the speed reduces. And when the dust is also collected, the weight of the blade increases. So even though it's dust, once it's deposited, the weight increases. So slight increase, change in the shape or the thickness or the amount of dust on the fan will actually increase the power consumption and reduce the output. So that is key. The other thing is greasing, because inside you there is a ball bearing, and you have to ensure that the friction losses are less. If it is making a noise, then they are also affecting to the power consumption of the fan. So those are the key things to remember with ceiling fans. So regulators, of course, we discussed. Then when it
Excuse me.
yeah.
For the blade matter, nowadays we are using aluminium blades.
Yes, aluminum blade is available, a bit expensive, but
It's
worthwhile
effective,
in
effective.
long term. Yes, long term it's worthwhile. Uh, so aluminum blades are also available as a replacement. So in industrial, we use this type of ducted fans where you have the fan between a duct and the duct is actually distributed among the space. So those are mainly in industrial type. So this type of you have a ducting system and you have the fan system installed in the common space. So that's a kind of a centralized system where you either have an exhaust or blower. So it can be blower and it can be also exhaust. So you will see this type of lures available. So sometimes they may be suction lures, sometimes they may be blowing lures. So depending on your aesthetics, they use different types of uh, grills so that you can ensure uh, aesthetics. But key thing is suction lures, it's difficult to identify. You will always see only the blowing lures. So because you will see air coming out, and if it is a comfortable uh, quality air, then you get the feeling. But most of the time, suction air is not identifiable. So, but you still have to ensure both of them are not blocked because they become like the nose or the breathing system or the lungs of the entire uh, ventilation system. So, the moment they are blocked, then they are having a hard time because of the resistance of air and it will not be able to give the correct output. So return path, so that's why we call it as the return path or the suction path, which is yeah. Now this is kind of a outside air intake, which is coming into an air conditioning system. So this is a fresh air supply given to a AHU kind of a thing. So of course you have to ensure at this intake you have sufficient filters, insect filters, etc., etc., and ensure they are cleaned at frequent intervals so that you can take the intake. So the return path has to be clear. So otherwise, not only the blowing path, most of the time we are only concerned about the air supply, but air suction also has to be uh, quite clear. And the other thing is lure positioning. Lure positioning, if you have lures installed at a very lower level, that is also not very good because one thing is it could absorb the dust content which is available on the floor, and there is also a tendency that somebody might push a cupboard or something like that and close the uh, intake air, so that can block the total ventilation system. Then, so that is about lure positioning. Then air velocity and duct sizing, there is actually a complete design. So depending on your duct sizes, the air velocity will increase or decrease. So there are limitations. Generally, we have it in the range of 2 to 3 meters per second. If it is going to about 6 meters per second, then it is kind of a you will hear a whistling noise. So that will also be a concern, and your flow rate will be the same, but then the airspeed, if the air speeds are increasing, then that could be a disturbance to whoever is inside. So duct sizing is critical because most of the time the designers or the investors or the contractors, they tend to reduce the duct sizes uh, and ensure that they are investment or their contract value is reduced, but the problem you will come across is you will have a lot of whistling. So whistling could be, and even they will look like jets when it come out of the diffusers. So if a person is directly seated there, then he will get a direct blow. So that is also not recommended. You have to ensure that the distribution is uh, equally distributed. Now, one thing is, now in this type of ducting system, you will see certain diffusers which are closer to the unit, closer to the blowing fan, will have very high blow. And when it comes to the longest path, or the most distanced diffuser, the airflow will be less. So to ensure equal air is distributed, you actually, we call it balancing the air, so that every lure is giving more or less an equal amount of air from the lures. So you do a measurement of the airflow, you calculate the airflow rate, and you there is a damper at behind these lures. You get a small damper. Damper is like a closure to the, whether I have a picture of a damper. Yeah, damper is something like this basically, where you actually close the space or open the space. So then you can ensure equal air is distributed in every system. So you manually adjust it, and you actually manually calculate what is the output of each lure. So it is a somewhat continuous process, because if you start from the first one and you decide how much of AI is should be coming out of the lure, you measure that, then you reduce that, then you go to the next one and you adjust that. So once you go to the last one, you have to actually come back and do for the second or third time. So it is a continuous improvement kind of a process, because once you adjust the first one, the next one will be higher. So it is a like a balloon where you make equal holes to take out an equal air distribution. So continuously, at least for about 3 times, you have to adjust the dampers to the value you require. Because sometimes if your adjustments is too high, then the air volume will actually reduce, and the longest one will have more air. So that is also not recommended. So that is with regard to duct sizing and air velocity. Then yeah, so these were the, so you get this type of round ducks also. Sometime back they were very popular, but now again people are again using square ducts. And also, other than aluminum sheeting, now you have this pre-insulated ducts as well, uh, which is lighter in weight. It's like a form between two aluminum foils. So, which is sheet form, which you can use for ducting purposes. Sure, whether I can show some pictures. Yeah, so it's this kind of a sheet. It's available in sheets, larger sheets. These are cut pieces. So uh, you cut it and make ducts out of that. So these are the made ducts. So these are lighter in weight. Since they are foam, they are actually fire rated, because sheet metal is definitely retardant to fire, but these could be fire exposed. So they are fire rated to ensure that even during fire, it will not catch fire, but it will melt down. Yeah. So they are quite lighter in weight, and they are actually insulated as well. So you don't need to actually insulate. But this type of metal ducts, if they are exposed, then it's okay. You can keep it without insulation. But if they are exposed, then you have to actually, if they are inside ceiling, then you have to actually insulate, because if they are in a different temperature, condensation can happen inside around the duct, and the water will start dripping to the ceiling. So yeah, so you have to insulate something like this, or you can use the yeah, this, what do you call it, Armaflex or Thermaflex. They actually brand names which are used to insulate the ducts and to ensure that condensation doesn't happen if they are at a different temperature. So if it is inside the ceiling, then definitely it's at a different temperature. But if your ducts are actually exposed, you don't need to insulate, because they are at the same temperature like the air inside. Yeah, so this will be the basic arrangement in a ceiling mounted AHU, where you have a return and four supplies. So generally return has to be larger in space, and ideally you can duct it, or if it is in multiple. So if it is in one enclosed space, there has to be at least one supply and one return. Otherwise, it will not circulate. So return air path is also critical, just like having the outside air, the supply air. So this is kind of a old type of AHU where you have the suction below. So those are not used much these days. If you are looking at cabinet split type air conditioning units, the suction is below. So that is not much recommended, because it is absorbing a lot of dust. And the other key problem of this type of arrangement is now generally the cold air is actually at the bottom of the room, because it's heavy, and hot air is on top. So in this type of circulation, it will not do the job properly, because you're sucking air from the bottom, you're sucking the cold air and making it further cold and bringing it. So it is not that recommended, this type of air circulation, but this is a better arrangement where you absorb from the top, and actually you can even supply to the top. So that is fine. Okay. So coming into now, how much air to actually provide for different spaces is actually given by the ASHRAE standard. 62.1 can be referred. Even fresh air is available in ASHRAE 55, if I'm not mistaken, how much of fresh air should be given, so that you do not give over air, or you also not give less air. So depending on they calculate based on two parameters. One parameter is the area, how much of area that you need to ventilate, and how much of people are actually inside that room. So depending on different requirements, now this is particularly for office building, so office space, reception, uh, there is telephone and data entry also, but the same figures are the same. So depending on the requirement, you have to increase or decrease the ventilation. So office building, they will take not densely populated, but if you take a classroom or something, or a seminar room where you have densely populated, where you have more people than office area, then the per person rate goes up, and even for the per person rate will actually increase. So depending on the requirement, the amount of air that you should supply to a certain area will be depending. So we are coming into exhaust system. So toilet is one key area that you will use exhaust systems to ensure that there is no odor. But this may not be required in residential and lower uh, dense rooms where only in a residence where only one toilet is available for few persons, but in office or schools or classrooms where you have densely populated, then the requirement could be more. Then you have to actually ventilate to take the order out, but to make whoever is coming next to be comfortable. And there could be also situations where in hotels you have kitchens, etc., where you need to take off the smoke out, because if the smoke is stagnated inside the kitchen, then it will be a very difficult breathing space, because it also can be CO2 and other pollutants also. So you have to extract them out, and you have to take out the smoke out of the kitchen area. So those are exhaust use. So these are other blower types. So these are called jet fans. So this is mainly for car park ventilation systems. You generally don't duct inside car parks. So you actually take it to a corner through these jet fans. So they are high RPM fans where you can uh, blow the air over certain corner and take it out from that point. So this is mainly on carbon monoxide control, because vehicles, I don't know whether still vehicles are emitting carbon monoxide, but it is at least during startup, it could uh, certainly emit certain amount of carbon monoxide. So to ensure that carbon monoxide is control, you have to have this type of jet fans. Now, the key issue with buildings is when to run these jet fans, whether it should run full time or whether it should run to a certain period in the time intervals where you run for 15 minutes for every hour or so. So it is very difficult to actually judge when to run the jet fans. So ideally, what we recommend is, if possible, to do a carbon monoxide monitoring, and then you uh, switch on the fan. So similarly, for even for fresh air supply. So even for fresh air supply, you can always monitor the carbon dioxide level inside the room. And if the carbon dioxide levels are rising, you can uh, take fresh air from outside and feed it to the space. Because fresh air coming into a conditioned space, fresh air will be at a temperature of outdoor temperature. So it could be 30 degrees, 32 degrees, which is coming inside, which is definitely a very high uh, heat, or where you need to supply high cooling load to reduce the temperature in that. So it could load up your air conditioning system. So that's why we recommend to use CO2 monitoring. And generally, outdoor CO2 levels are in the range of 200. Certain areas might go up to about 400. So your fresh air fan operation can monitor even to about they say outdoor plus 700. You can go up to about 1000 ppm. So if your CO2 levels inside the room goes beyond 1000 ppm, you can switch on the fresh air fans. So this will save a lot of energy rather than the fresh air fan running all the time, or you are trying to ventilate uh, the room with complete fresh air. But there could be also AHUs where they use, so apart from the standard AHUs, you can install a separate AHU to actually control the entire fresh air system. So this is taking complete fresh air from outside. So it is actually cooling it down here inside the AHU and then supplying it to the space. So that is also another best energy efficient practice where you have you call it primary PAU, primary air handling units, where you absorb the fresh air from the space and uh, reduce the temperature and then supply to the system. So that is another uh, efficient measure that you can actually adopt. So we were actually looking at, yeah, these jet fans where you can operate these depending on the carbon monoxide level. So if the carbon monoxide levels are not that high, you need not operate them because it's fans which are running in vain and there is no purpose. So this is the particular fire control or staircase pressurization which I discuss, which is given in a diagram where you have multiple uh, flows. So this particular flow is on fire, and there is actually a smoke control system also exhausting from here. So it is sucking air where you run the exhaust fans completely. So they have designed in such a way that you run the toilet exhaust or additional exhaust system to ensure that the smoke inside the building is removed. And this is actually blowing air, and you actually pressurize this part of the building so that the staircase is fully ventilated and always the air path is from the staircase to the floor. So the fire will not be coming inside the staircase, and you can ensure that the people even above the floors can actually come down. So you pressurize the system and there is a pressure control. So if the pressure goes beyond, you can actually take it out because high pressure also will be uncomfortable for the people uh, coming down. So, so this is also part of the smoke control where you have exhaust to take off the smoke from the space. So heavy ventilation also will increase the fire spread. So that's why you have to be very careful whether you're actually using this type of smoke control system. Yeah. So basic maintenance of uh, this type of ventilation system, even part of air conditioning system. So wherever air is circulated, you will not get pure air coming into the system. You'll have to install a lot of filters and a lot of insect control to ensure that no foreign particles are entering the space. So the disadvantage is they could get clogged. Uh, and when it gets clogged, then the blowing does not happen to the optimum level. And actually the pressure inside the space also increases trying to blow air. So you actually in AHUs, you monitor the duct pressure, we call it, or the differential pressure. So the pressure difference before the filter and after the filter to actually see whether the filters are clogged. So regular maintenance of the filters is important so that you get a proper blowing, because if the air circulation in particularly in an air conditioning system is clogged, then your temperature might come down, but your humidity is not going to come down because the condensation, that is the water which is available inside the room space, is actually condensate at the coil. Condensation happens at the coil. So if you remove the water only, the humidity will go down. Otherwise, the humidity also will not reduce. So to ensure the humidity is reduced, you have to ensure proper air circulation. So at what intervals to the filter cleaning to happen at what intervals is very difficult to judge. It depends on the space you are in, and it depends how much your air is polluted. So if you are in a city area or in a congested area, then the frequency of filter cleaning will have to happen frequently. Otherwise, your entire uh, indoor, now indoor also inside this, you get the same fins which are available just like the outdoor. So indoor fins, if it gets clogged, then the proper heat transfer will not happen. So sometimes, uh, you also have to wash the indoor part. So at least once a year or twice a year, they actually wash the not only the outdoor coil fins but also the indoor fins, so that you take off any dust which has actually passed the filter and come inside and which is clogged inside the fins. So that is one key important. The other thing is this type of cups and uh, rotating particles and belts. So if the belts are too tight, then it is a problem. So you have to ensure the proper distance is maintained, and if these bearings are not sufficiently greased, then the friction losses increases. So all that will depend on your power consumption to the uh, fan system. So some if you take kitchen exhaust and things like that, they don't have direct motors installed to the fan, because with the kitchen exhaust you get certain amount of oil particles also coming inside. So you have this type of a belt driven system where you have only the fan inside, but the motor is separated. And even some cooling tower fan system also, you are using this type of separated motor with the fan to ensure that the motor is not damaged through any uh, water vapor or oil vapor which is flowing in the duct. The other, so filter cleaning, cleaning blades, lures, motor bearing and motor belts. Motor bearing is also another important aspect where you ensure the noise. You can even actually do when I have a thermal imaging part. So thermal imaging to see what is the uh, temperature the bearings is and the temperature of the motor, so that you know there is some increased friction in certain part of the motor. Okay. So this is a kind of a now exhaust heat system recovery, which is mostly used in India, but I don't know, in Sri Lanka, we do not practice this type of heat recovery systems, where you have where you recover air from the exhaust, because now you're exhausting, even if you're exhausting from a toilet or a kitchen, the space could be an air conditioning space. Then you're pulling out air which is conditioned, where it is at a lower temperature, and you're taking it out uh, and just taking it outside, which is a heavy energy loss, just like a blow down of a boiler system, which we discussed. From a boiler, you blow down the high dense water. So here you're removing an odor or removing a bad particle like carbon monoxide or CO2 from a conditioned space. So in this type of situation where you have the return air coming here and you exhaust it to the outside, and in the same system, in a partitioned area, you have the outside air coming in, and this becomes the fresh air supply. So this wheel actually rotates. So this is a kind of a heat exchanger which will absorb the cool which is passed through the return air and bring it here to the supply air. So this wheel is rotating very slow, so that there is enough time for the heat transfer to happen. So it is absorbing this particular material like a radiator fin kind of a thing. It absorbs the cool. So the air systems are not mixed because the return air is highly polluted. It could be CO2, it could be carbon monoxide, it could be an odor. So they are not mixed, they are totally separated. So this unit is actually transferring whatever cool which is available to the supplier side. So this is very much used in India, uh, which even for default air conditioning systems, they install this and make a lot of savings through the exhaust and supply air. Yeah, so this control part is there what we discussed. So there are CO2 sensors and you have air dampers to actually control the air level coming in. So this is a CO2 sensor. So this will be installed at the office space. This actually has to be installed at a very low space as I got recently stuck installing this at the duct level. So it was too high. So you have to install it at a like a table level, like a breathing space level, we call it. So that you actually get a proper reading of the CO2 level of the premises. And depending on the settings on this, you can send a signal to a motor controller and you can switch on the fresh air fan. Okay, so this could be even speed level regulated or VSD regulated. Because you will see, we will discuss if the RPM comes down drastically, you are saving energy on the uh, third order because RPM to the power is on the තුනේ බලයට තියෙන්නේ නේද? So it's on the third order, so you are cutting down a lot of energy. So if you can reduce the speed depending on the CO2 level, so if it is goes up very high, you can go to the full speed. Otherwise, you can have a minimum speed. So if you think VSD is very costly, you can also do the speed level regulation where you have about 2 or 3 speeds. So that is also quite worthwhile. Then you have a simple contactor system and you instruct the controller to which level the speed should be increased. So that is very much effective, just like a fan control. You have maybe 3 speeds or 5 speeds sometimes uh, to have the correct level of air supply. So you are not giving more fresh air or you are not actually compen compensating on the CO2 levels. Yeah, so these are speed control. Yeah, and exhaust air can be on timer driven as well. Things like toilet exhaust. Yeah, most of the time what you do is you couple it with the light. So whenever somebody switches on the light to move in, the fan actually runs. But this is also is okay for a medium traffic operation. But generally, if it is high traffic, we recommend to go with timers. So during the day when the office is in operation, you can ensure the exhaust fans are running continuously, or you can do a for every 1 hour you run for about 15 minutes, or you run at about 5 minutes, then the next 5 minutes it is off. So some amount of time interval you can set for the fan to operate, because not only when the order is generated, so when you switch on the bathroom lights and come in, the order will be there. So generally the fan should operate actually after somebody uses it. So that is where the requirement is. So that's why generally we don't uh, recommend for medium traffic or high traffic coupling the exhaust fan to the bathroom light. So next we are moving on to pumps actually. We are talking about liquid transfer pumps, mostly talking about water pumps. So pumping systems basically can be on two modes. Open loop system where you actually maybe pumping water from a ground sump or a groundwater system to overhead tank, where it is released to air. So it is at a height and you have a atmospheric pressure there, or it could be a closed loop system, uh, like the pumps in a chill water circulation system. So it is actually getting circulated. So the difference is in a circulating system, whatever the height you reach, since it's a closed loop, uh, you get a back pressure head. Even at the inlet, you get a head. So you have to actually only supply, the pump should actually supply only the head loss. So you are not supplying the height difference. So that's why you will see most of the high-rise buildings, they have the cooling tower site on top and the pumps right at bottom, and the chill water, the chillers are also at the bottom. So if it is not a closed loop system, then if you are circulating only one side, then you have to actually give the water head as well, because you have to, there's a head difference. But in a closed loop system, there is no head difference, because you are getting the same water back to the pump and you're only circulating. So it is only a head loss that you have to provide from the pumps actually. So, but in open loop system, this height of the tank and how low your well or sump is will all add up to the uh, head, and that entire thing will have to be provided from the pump. So pumps also you will see in different shapes and different constructions. So these are mostly booster pumps, submersible pumps where you can put this inside water and operate, and overhead pumps, then this type of tube well pumps. So they are in various shapes and technologies. Okay. So this is basically a nameplate of the pump. So key things to look at is water head and water flow. So here you will see head at 40 WFT is water feet. Then GPM is gallons per minute. That is also giving the flow. So there are different units used. You ideally we give the head in meters and flow rate in cubic meters per second. But there are certain other units used, so you should be able to convert and compare between different units. So GPM will be in gallons per minute and water feet. Then you have the power in terms of horsepower or in terms of kilowatt. So sometimes they are not marked, and you'll have to look for manuals and catalogs to see actually what is the pump power. So generally for this type of open loop and water uh, pumping to the uh, to overhead tank, um, where we call it a transfer pump in building services terminology. So key is you have to have the head. Head is a must. So your head will be this. So your head will be this difference. Uh, the height of the water level to the top of the tank plus your suction. So this we call it your suction head and your supply head. So if your pump is here, then you actually providing the head difference. So the height difference plus whatever friction losses you are having in the piping system. So ideally, if you are doing a piping from a submersible to the overhead tank, it has to be with minimum bends and minimum fittings to ensure the friction loss is minimized. But with distance, there is a certain friction loss which you can't avoid. But ideally, you avoid the path you actually minimize, the shortest path, and you minimize the number of fittings. So that head is another key. The other important fact is the flow. Water flow is generally, I would say, in most of the buildings, they uh, mismatch this water flow. They go for a very high water flow rate. Because if the water flow rates are high, the only advantage is you can ensure that the tank is filled quickly. But the problem is with the high flow rate, your water increases. So generally, I recommend you go for a low flow rate, but there is a limitation of design where you can't go for a very low flow rate also, but select the lowest flow rate, which is enough for the consumption. So if your distribution system is not requiring such a high flow rate, the pump kilowatt can be saved and the pump capacity can be saved, and from your in the network you can cut down the demand for the pump power. So that is a key thing. Most of the apartment buildings, they have very big pumps, very high capacity pumps, to ensure that they only run for about 1 or 2 times a day. So the entire day's consumption is actually filled in 15-20 minutes, which is a relatively very high flow rate. Uh, but I rather recommend you go for a low flow rate or matching the flow rate of the uh, consumption. You can make it little bit higher, so you fill up the tank quite slow. So that will reduce your power the demand charge actually. The kWh energy will not be a difference, but your demand can be reduced from reducing the flow rate. Then a little bit about yeah, so these were the key things that we were discussing. The head, okay. So you're pumping up to this point, and if you're pumping it from a sump, then there is a negative head also. So these are limitations. You have to ensure that this negative head or the suction head, we call it, to minimize because that will be the most difficult part for the pump, because they are actually good at pressurizing and giving an output. They actually suction is very bad in all the pumps. They are actually good at pressurizing and giving a better output. So this negative head is actually limited in most of the pumps, even though they have a very high head. So ideally, if you can do this type of arrangement where you always have a positive head, and where water is through gravity or even at a height flowing into the pump, then the pump has to only supply uh, to this positive head part. Okay, so that will benefit uh, the pump operation. Most of the fire pumps now, they require this type of arrangement, because there is a risk in this type of arrangement. If the pump is at a higher level than the sump, then if there is any leakage in this what do you call it, float or the valve here, the entire water can come down, and the pump will run dry. But in this type of arrangement, you have the water coming in to the pump at gravity, so there is always water inside the pump, so the pump will not run dry. Because pump cooling, during design, they have assumed certain amount of cooling happens because of this water circulation. Not only it's not a air cool thing, so this water is actually used to cool the pump and the motor as well, to keep it at a good temperature. So if it is running dry, or if it is just running without water, then the pump could be damaged. So fire pumps essentially these days has to be this type of arrangement, where you have to take the pump to the bottom of the sump. So these are actually costly construction, where you have to have a separate pump, underground pump kind of pump room kind of a thing, to ensure that the same level is maintained. So in this type of arrangement, the water will not, the pipes will not run dry, or the pump will not run dry. So when it comes to the efficiency of the pump, there are several components. Now, pump and the motor are two different things. Although in domestic we get it as a single unit, but when it comes to industrial pumps, you get actually a lot of components. The pump part, the casing part, there is a coupling part, and there is also a motor. Okay, so if you see high capacity pumps, you will see this entire range. Okay, so all these will add to the efficiency actually. Uh, so most of the time you align them properly, because misalignment will be a big problem. You use a laser beam to actually align them correctly, the coupling and the shaft, because if they are misaligned, then also your motor consumption, power consumption will increase, and your pumping output will reduce. So all these will come into play. So on an overall efficiency, it is this output, pump output into the motor, power consumed by the pump. Okay. So these are their individual efficiencies. Okay. So ensuring pump operation efficiency, pipes is key. Correct size of pump pipes. So, and if you are using metal pipes, then you could fall into this type of a situation where the pipes inside is clogged. So they could be either clogged through any impurities, or they could be due to corrosion, or they could be due to any like if you are taking water with heavy hardness. So gradually this could deposit and it could come to a range. So this will happen, I think, after so many years, where the piping space is actually reduced and the surface roughnesses have increased. So all these will have to be counted during the pump design, and they will actually add up to the pump head. Okay. And the water flow rate. So generally we design pipes to have 1 meter per second water flow rate. Uh, but lower than that also is better so that you have uh, less friction. So lower the diameter, higher will be the friction. And the other thing is proper fittings. Now, generally, you may have heard of plumbers, they are very reluctant to use 90-degree or elbows. They actually use, sometimes they use 45-degree bends, or they use bends. Bends are gradual circular uh, turn, which doesn't happen at 90 degrees. It's not an elbow. So that will actually reduce the uh, pressure and increase the pump head. So, and that could be a situation where a pipe burst can happen in that type of a location. So, T's and elbows are critical in a pumping system where damages could happen, and also those are risk areas and they actually adapt to the pumping head. Then definitely shortest possible routing is one other thing. Then maintenance, again you will have filters and strainers. We didn't see filters in a piping system. They are actually called strainers, not this. Yeah. So these are called strainers which you install in pipes. There is a direction to install. You will get the arrow mark somewhere here. So generally they are installed before the pump. So to ensure that the pump is not uh, getting the impurities, whatever coming from the line. But the risk is you get this type of a filter inside, and you can remove these nuts and take it out. And the risk is if they are clogged, then the pump is actually sucking and uh, sucking air, which will be difficult for the uh, because of the clog. So that is very dangerous. So that's why you have to ensure that you clean these trainers not frequently, but most importantly, before you start up a system, because there'll be a lot of impurities inside the piping the moment you do the first run. There'll be a lot of like even metal parts after the welding process and any corrosion. So those things will actually get collected. So during the first commissioning stage, you have to ensure that these strainers are cleaned frequently. Okay, and you take out all the impurities in the system. So once the first run is done, generally it is less headache to the strainers, but uh, I don't know whether there's automatic method of looking at these systems, but uh, at least during maintenance and overhaul, you have to ensure they are actually cleaned up. Then water treatment is the other key where something like this could happen if the water is very bad and if you are actually pumping, like we discussed, the hot water systems. If the hardnesses are high, then there'll be deposit of calcium carbonate and any other dissolved solids in the piping system and will increase the friction losses. Mhm. Blowdown is something with regard to steam systems and boiler systems, which we have discussed. Yeah. Improving pump efficiency. So this is a typical pump curve, which you have to drill down from the pump supply. They are also very reluctant to provide, but nowadays you can, because efficiency is concerned, in those days you actually give the size of the pipe and get the pump. මෙච්චර උසකට පම්ප් කරන්න අංගලේ පයිප් එකක් කොහොමද කියන්නේ so but nowadays you actually look at a pump curve and then select a proper pump. So this is actually your system curve with the flow and the head. And this is your pump curve. So you select a pump curve to actually coincide with the system curve. And this is the efficiency for this pump curve. Okay. So if you take the highest efficiency point here, which is the maximum efficiency, the pump should ideally operate here. Okay. But it's actually coinciding here, so it's actually operating here. So this is your duty point. So then your actual efficiency is here. Actual efficiency is here, so this is the drop of the efficiency. And if you take the power consumption, so at the best efficiency point, the power consumption is this, but the actual power consumption is here. So these are the three curves: the power curve, the efficiency curve, the pump curve, and the system curves. So all of them are drawn in one graph so that it is very easy to actually find. So ideally, your duty point should be as close as to the best efficiency point. If you can coincide, ideal, but very difficult to coincide. So you generally take a little bit of a higher capacity and target somewhere here without targeting the best efficiency point, because with time the friction losses will increase with the piping and system and you will start moving here. So that is not a very good situation where the flow also will reduce. So you actually target somewhere here so that even later you're actually moving closer to the best efficiency point. So since it is that difficult to actually select the correct pump curve and you don't get all pump curves to your system requirements, you have to select one curve which is operating closer to the best efficiency point. You do different modification to the pump to ensure you come closer to this point, which is mainly discussed under impeller trimming and VSD. Okay. So if you do an impeller trimming, you cut it off. So there is bit dangerous. You can't paste it again. So there is a risk of doing it correctly. The only advantage is cost effective. But whereas VSD could be very expensive you need to install. So when the impeller is getting trimmed, the pump curve comes down. Okay, when the pump curve comes down, you can select a pump which is suitable to your system curve at the best efficiency point. Okay, but the danger is if you overcut, then you're actually going below the best efficiency point and you have to actually replace the impeller. Whereas VSD is something very easy to handle. So you get speed curves. Pump curves when you install a VSD, you get speed curves. So this is your 100% speed, 90, 80, 70, blah, 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 it comes down. And if this is your system curve, and if this is the BAP, you run at a efficiency of 70%, maybe speed of 70%. So the advantage is you will not go wrong. Even if you go to 60, you can always come back to 670 and say, okay, this is the exact point we want to operate. Okay. So that's the advantage of VSD. And efficiency also you can maintain, because when the RPM comes down, the efficiency also curves will shift, and you can go to a acceptable efficiency rather than running totally inefficient. So ideally, since it is at 1/3 with the RPM to the power, you can actually reduce the power consumption drastically with the speed reduction. Okay. So in certain situations, people used to install VSD just to tune the pump, to get to the best efficient point. So that is one recent advancement where people use VSD. So if the pumps are over designed, you use a VSD and to reach the best efficiency. But the actual VSD operation will be with varying flow rate. Now, if you take this type of air conditioning system where the water is getting circulated and you are supplying whatever heat exchangers or AHUs, now your cooling load will vary depending on the number of people inside the room and the weather condition. So you may not need to circulate the same amount of water all the time. So good old days, we had a bypass for the HU or the heat exchanger. When the temperature reaches whatever your set point, say 24 degrees C or whatever, your set point, you're bypassing the water, because this pump is running at a constant speed, and you can't actually stop the water because the pressure levels in other systems will go up. So what you do is you actually bypass the water. ඉතින් මේ water නිකන් circulate වෙනවා bypass mode එකකින්. But nowadays what we do is we don't bypass, we use a valve here and shut the water flow here. So once you shut the water flow, the pressure near the at the out of the pump will start rising, because now the system is smaller. මෙච්චර දුර යන්න ඕනේ නැහැ. You මේක වටේ ගිහිලාම ඇති. So once the pressure increases, you installed a VSD plus a pressure control, a pressure sensor to actually monitor what is the pressure, and you have a set point for the pressure. So depending on the pressure, you reduce the RPM of the motor. Then the pressure comes back to what is your set point, and we circulate water in the same system. So similarly, once this closes up, again the pressure increases, then the VSD will reduce the RPM further and reduce the water flow rate. So this is a variable type of water flow rate. So similarly, this can be done even for a condenser cooling tower water flow rate as well. And ensure that you are circulating only the chill water that is absolutely required. So that will save a lot on surface losses and pump flow rate losses. So there are major savings achieved by installing VSDs for this closed loop where you need a variable speed, variable flow rate. So in different times, you need a variable flow rate. So similarly, even with airflow, now if you don't have a cooling tower system, if the cooling tower has reached the particular temperature, you can actually reduce the flow rate of the fan. So there is not major savings achieved by condenser flow rate, condenser flow pump, VSD, or the cooling tower pump. But if you are trying to go to the optimum, then there are also adjustments. And even where this air duct distribution system in this. So if the room temperature has reached 24, you need not keep circulating air in the room. Until the room temperature increases, you can always ensure that it is not required to circulate. So you can shut the airflow. You have the damper, you motorize the damper and shut the airflow and reduce the speed of the blower fan, just like the pump. So those are mechanisms which we call VAV boxes, variable air volume. You control the airflow in those cases. So those are critical energy efficiency measures that can be implemented to ensure your consumption reduces. I think those are the key things that we want to discuss. Yeah, so this is the misalignment I was discussing. So if your pump and your shaft and your coupling is misaligned like this, is actually an actual measurement. I don't know whether you see, you see the pump here. So I'm taking the laser and temperature sensing the coupler temperature. So it is at 75 degrees C, which is not acceptable. So there is a problem with the alignment. So knot bearings, coupling alignments, water leakages definitely. Yeah, even pressure sensors in VSD could be a problem. So your pump speeds are not reducing. So they are the things that you will have to keep in constant monitoring in a pumping system. Shall we have a quick break and come back? Very boring, maybe. Any questions? 19ක් ඉන්නවනේ. ඔක්කොම B2ද? Again, reminder B2 assignment at least subject 1 to give the eligibility for exams. ඔයගොල්ලන් number index number එකත් එක්ක එවන්න. So I have to fill up and send it across. So today and tomorrow I'll give you time. By Monday I'll send it across. Any questions? Somebody was trying to ask.
I sent that list for you.
Okay. No. Thanks, man. Okay. අපි විනාඩි 15කින් වගේ යමුද ආයේ?
Okay, sir.
Okay, thank you. Shall we start? අලුත් ප්‍රතිඵල ඇවිල්ලා තියෙනවා දැක්කද කට්ටිය?
25% increment.
ඒ 17 කිව්වට 20 25 නෙමෙයි සමහර මේ ෆැක්ටරිස් වල 50ක් විතර යනවානේ 100ට. 40 පැනලා යනවානේ.
ඊළඟ බිල අරන් බලන්න ඕනේ. හැබැයි නෑ මෙහෙමයි මෙතන මේ තියෙන ටැරිෆ් ටික කලින් බිලකට දාලා කැල්කියුලේට් කරලා බලන්න
එහෙම
පුළුවන්.
තමයි කරේ. එහෙම කරලා බැලුවාම මම ක්ලයන්ට්ලා බෙරිහන් දෙනවා. මොනවද අපි කරන්න කියලා අපිට බෙරිහන් දෙනවා. අපි මොනවද කරන්නේ?
කේස් එක.
දැන් ඉතින් වෙන්නේ වැඩි කට්ටිය පුළුවන් තියෙන පොඩි කට්ටියත් ඔක්කොම සෝලා දායි. එතකොට ඉතින් ආදායම මෙහෙමම කියලා වෙනවා කොහොමදත්.
ඊයේත් ඕක මේ මමත් ඩිස්කස් කරා කොයිම විදිහකටවත් හදාගන්න බෑ ගයිඩ්ලයින් එකක් යන එනර්ජි බිල් එකයි ගෙස්ටවත් ඔකියුපන්සි එකටවත් මීල් පැක් එකටවත් මොනවා කරත් එන්න උඩින් ඉන්නේ.
ඔය අර ඕකේ බැංකුවට තියනවද?
බැංකට් එකක් නෑ සර්.
බැංකුවට නැතුව
බැංකට් නැතුව සාමාන්‍යයෙන් දැන් මං හිතුවා කොයි විදිහටද මෙච්චර කරන්න බෑ දැන්. ගිය පාර 1.1 මිලියන් ඇවිල්ලා තිබ්බා. ඔකියුපන්සි එක 40%. ඒ සාමාන්‍ය එක ඔකියුපන්සි එකකට 20000ක් විතර යනවා එනර්ජි. ගෙස් කෙනෙක්ට මම බලලා රුපියල් 5000ක් විතර යනවා එනර්ජි.
Here the room rates roughly 40,000 40ක් විතර.
35ක් විතර වගේ යන්නේ. නේද මම ඉන්නේ දැන් ලබන මේ දැන්ටමත් ගයිඩන්ස් දීලා තියෙන ඊළඟ මේක ඉඳලා හරියටම ස්ට්‍රික්ට්ලිම බලලා මෙව කරනවා මම දැන් ඔපරේට් කරන්නේ නැත්නම් මම හරිය කරනවා ඉතින් වෙන කරන්න දෙයක් නැහැ.
ඔව්.
ඩේලි විසිට් කරලා හරි ගයිඩන්ස් දාලා පම්ප් ඔන් ඔෆ් කරන වෙලාවල් ලයිට් ඔන් ඔෆ් කරන වෙලාවල් ඉස්සෙල්ලා ඒකෙන් කරන්න ඕනේනේ.
AC එක මොකද්ද?
AC ස්ප්ලිට්
ඉල.
ස්ප්ලිට්
ආ?
ස්ප්ලිට් තියෙන්නේ
කොහෙද මේ?
විලාස්වාදු. ඒක මෙව්වනේ තියෙන විලාස්නේ තියෙන්නේ.
ඉන්වර්ටර්.
ඉන්වර්ටර් තියෙනවා නන් ඉන්වර්ටර් තියෙනවා. මේ 24000 තියෙන්නේ. සාමාන්‍යයෙන් රූම් එකකට මම ඒවත් හැදුවා මාර කැල්කියුලේෂන් ටිකක් මම කරලා තියෙනවා ඩිසයින් ලෝඩ් එක කොහොමද එන්නේ එතකොට එක ගෙස් කෙනෙක්ට කොච්චර යනවද එහෙම කම්පැරිසන් ටිකක් හැදුවා පරෝණ පෙන්නන්නත් පුළුවන් සර්
මුළු විලායකම එයා කන්ඩිෂන්ද කොහමද ඉතින් ගේ සාපු ගම ඔය ගෙවල තියෙන ඉඳ ඔක්කොම AC ටික දානවා.
ඔව් විලායක කියන්නේ එක රූම් එකයි තියෙන්නේ ඒකේ පොඩි ප්‍රශ්න ටිකක් තියෙනවා අර ඩිසයින් එකේ මේ බාත්රූම් එක එක්ස්පෝස් ටු එයා ඒ දොර ඇරියාම හැමතිස්සෙම කොච්චර හදිසියක් බාත්රූම් එකේ දොර ඇරලා AC එක දාන් හිටියොත් ලොස්
ඉවරයි.
ඉස්සරහා තියෙන ලොකු ෆ්‍රෙන්ච් වින්ඩෝ දෙකක් ඒ වින්ඩෝ එක ඉතින් සමහරවිට ගෙස්ලා වහන්නේ නැහැ කර්ටන් එක විතරයි වහගෙන ඉන්නේ
ඉතින් ඒකට පොඩි ස්විච් එකක් දාන්න.
ඒක තමයි මමත් ඒවත් කල්පනා කරලා තියෙන්නේ දැන් අර
ඒකයි අතන්ට ඩෝ ක්ලෝෂර් එකක් දාන්න. නැත්නම් ඒකටත් ස්විච් එකක් දාන්න.
ඒ දෙකම
AC එක ඔන් වෙන්නේ නැහැ. අරක අරපු ගමන් AC එක ඔන් වෙන්නේ නැහැ.
ඔව්
බාත්රූම් එකට ඩෝ ක්ලෝෂර් එකක් දාන්න. ඉතින් ඒක ඇර යනවනේ.
බාත්රූමේ ඩෝ ක්ලෝස් එකක් දාලා අරක මේ ටික වෙලාවක් මේ ටයිමර් එකක් හරි දාලා ඔන්න ඕෆ් වෙන්න දැම්මනම් හරි නැත්නම් යන්නේ පාරට ඕක මේ මෙව්වා වෙනවනේ
ඔව්. ජනෙල් ඔය මේ ෆ්‍රෙන්ච් වින්ඩෝස් වලට නම් මට මතකයි එක ස්පේස් කොහේ හරි දැම්මා ඔය මේ ස්විච් එකක්. ඒක ටච් වෙලා තියෙනකොට තමයි ස්විච් එක ඔපරේට් වෙලා තමයි අත අරකට පව යන්නේ. නැත්තම් AC එකට පව නැහැ.
වෙලා තියෙන නිසා ඒකට අරිනවා ගානක් පාරක් පාසා ඔෆ් වෙනවනේ ඒකත් හොඳ නෑනේ
ඒ දුන්නට දැන් ඒගොල්ලෝ හදා ගන්නව නේද ඔය ටික.
ඔව්
I mean ළඟ අල්ලන්නේ නැහැනේ. කොහොමද ස්පේස් අල්ලන්නේ නැහැනේ ආපු ගම.
මේ ඒක හරි මම තෝකත් කල්පනා කරා ඒකට මොකක් හරි ස්විච් එකක් හරි එහෙම නැත්නම් ටයිමර් එකක් හරි දාන්න අතින් ඔන්න උනාම
ඒක කොච්චර ඉෆෙක්ටිව්ද කියලා ඉතින් ඒක ලොකු කේස් එකක් නෙමෙයි. ඉතින් යුරෝප්පාවේ තමයි යුරෝප්පාවට ඕනේ නෑ ළඟ ඔය
නෑ යුරෝප්පයි හොඳ යුරෝප්පයි
ඒෂියන් ලා තමයි හදාගන්නේ.
ඒ මිනිස්සු හරි ඉෆෙක්ටිව් එහෙම AC දාන්නෙත් නෑ සමහර වෙලාවට ඒ කට්ටිය ටවල් එකක් උනත් පාවිච්චි කරන්නේ නැත්නම් ඒක අර ගයිඩන්ස් වලට කරන දැන් අපි ගයිඩන්ස් එකක් දීලා තියෙනවා මේ පාවිච්චි කරන එක බිමින් දාන්න අනිත් හොදන්න ඕන ඒවා ටැග් එකක් තියලා තියෙනවා ඒ මිනිස්සු ඒවා හරියටම කරනවා ඒගොල්ලෝ ටවල්ස් ඕන නැත්නම් ඒ ටවල්ස් ටික ඒගොල්ලෝ ඩ්‍රොප් එකේ දානවා පාවිච්චි කරන ටවල්ස් ඒ කට්ටියව දෙන්නෙක් ආව තවල් හතරම පාවිච්චි
හරිනේ අපි කරගෙන so we are moving on to a little bit on the generators. So these are mostly used during backup time, so not much of a usage, but there could be situations where during power failures and stuff like that where you have to use the generator. So mostly diesel generators, roughly if you take efficiency, we can call it our known terms. Generally, 1 liter should produce 3 kilowatt hours. So that is an important parameter that you can check. You measure the kilowatt hours from the generator and the diesel consumed. And see what is the ratio. So just like a vehicle efficiency thing. So roughly it should be in the range of 3, but most of the generator that I have come across is not running at that. And the other key issue is generators, at least they should be 40% loaded. That is a must on the generator side where the engine bearings, packings will have issues. If your generator is less loaded, so that is also ensure. So if you are having, if it's a bigger facility, then plan it for multiple generators of different or smaller capacities, so that you can equally distribute the load and you can depending on a heavy load, you can introduce more generators. So roughly, currently, if you take at 350 diesel price, so roughly it comes to about 120 rupees per kilowatt hour. So this is another very costly operation to run. So generator room, if you're looking at energy efficiency basic stuff, just like an engine, oil changes, filter changes, and overhaul. The other key thing is generator room. How you have installed the room, because generators, the key point of overload is not the power, more than the power, the temperature levels. So it will be looking at whether it can cool down to the rising temperature due to the load. So you have to ensure that the room is designed properly, because it will be in a ventilated space. So this is where the radiator part, or this front part, which is exposed to outside, where you are actually, I'm talking about air cool generators, where you take out the hot air, and you have to have a proper suction. So if the suction is blocked, or if the suction is not giving enough air, suction has to be generally bigger than the exhaust, because suction is not forced. So suction air and this room space is very important, so that you properly ventilate the generator. And of course, the smoke exhaust, you anyway have it outside and not inside the room space. So this is key to the generator room arrangement, to ensure that the generator is running at a acceptable temperature. Okay. And in addition, you can have room ventilation as well, if it is a very big generator, to again ensure cooling. So cooling is very important with the generator system, and the water circulation. If it's a radiator thing, you'll have water jackets just like the engine part. So looking at water levels, just like a vehicle engine, you have to ensure cooling happens exactly. So ventilation and exhaust is quite critical in generator room and generator efficiency, but key thing is this ratio. So check whether you are running at that ratio. So if it is not, what is the problem? So maybe the generator is running at a very less load, so that it is consuming, it is fixed.
So excuse me,
Oh,
අර කිලෝවොට් hours කියන එක මෙෂර් කරන්න පුළුවන්ද? ඒක රීඩ් වෙනවාද ජෙනරේටර් එකේ තියෙන ඩිස්ප්ලේ එකේ?
සමහර ඒවා තියෙනවා, සමහර ඒවා නැහැ. සමහර ඒවා තියෙනවා.
ඔක මට ලොකු ප්‍රශ්නයක් වෙලා තිබ්බේ. ඒ කියන්නේ එහෙම නැතුනොත් අපිට වෙන එනර්ජි මීටර් ඉඳලා ගන්න.
එකක් separately දාන්න වෙනවා.
හරි.
මේක out එකට. හරි අතන in එකට.
Okay sir.
අපි සෝලා කරාද?
නෑ sir.
ගිය සතියේ ටිකක් කරා.
ඊ සතියේ මටත් ඒක මේ hot water නේද?
solar water කර. solar hot water.
ඔව්. මේකේ වැඩි දෙයක් මේක ගොඩක් දුරට කරනවද මැද්ද කියලා. මම ඉතින් මේකේ ඉතින් basic thing I didn't want to touch much. So this is something last, and almost all of you all know with the current situation, with everybody trying to do solar PV installation for the purpose of generating electricity. And sometimes you start with this, but I actually do this at the last. First, you have to ensure your efficiency levels are met, and you reduce your demand and your consumption first, and then you size the solar. So you may not be able to give the entire facility with solar power, but you'll be able to cater some amount through installation of this type of photovoltaic panels. So the idea is we'll take from a basic residence, you have this type of panels installed on your roof, and this is generating DC. because what is inside the panel is actually a junction, a PN junction, and it will start circulating a current once you get light, not heat. So you have to have these panels directly or perpendicular to the sun to ensure that you get the optimum. So DC current is generated here, and that you convert to using an inverter, you convert to your system frequency, AC frequency. So good old days, we used a battery pack to actually store this energy, take it back, because most of the time, if you take a residence, the solar power will generate during the day, but your consumption will be mostly during night. So you have to store your energy somewhere to use during the night. But now what we call is an on-grid system, where you actually invert from the inverter, and if the residence is not having that load, so it will first supply the residence, because that is the shortest path and lowest resistance path. So your inside residence load will be supplied, and whatever extra will actually get, we call it exported. You're supplying to the national grid. So national grid is your actually the kind of the battery bank. So you store it in the national grid, or actually somebody else is using. And during night, you're actually importing. You're asking back that energy to actually for your own consumption, where this will be zero during night. The other way out is to use a battery backup storage, where you put your extra to the battery pack. And still, if you have more extra, then you can export. You put it to the battery pack, and when you want it, you take it from the battery pack. But the issue is charging the battery and discharging, there is about a 20% loss. So, batteries are not quite reliable in good old days, but these nowadays you can get about 10-year battery warranty. Whereas solar panels is just installed and forget it. You can that will run for about 40 years, and they even guarantee for 25 years performance. So solar panels, there is no issue in maintenance or monitoring, but battery packs you have to frequently monitor and maintain and replace. So that's why battery packs were not very popular. So you use on-grid system, where you actually export to the grid. So if you are having the battery pack and not connected to the grid, we call it off-grid system, which most of the very rural and out of reach, where grid is not available locations, we use type of off-grid system. But nowadays, what is popular is the hybrid. You have the both systems, where you store energy in the battery backup as well. And apart from that, if you have furthermore, then you can actually export. So the advantages are these numbers. Without running the generator, if you do this, still with the 20% loss, still you can supply your system. So a lot of installation which had on-grid systems which were very high capacity, but they were struggling during the power failures, where they couldn't run the solar system. The solar is generating, you can't use it for your own requirement, or you can export, because the grid is not available. So you have to run the backup generator, which is now allowed to have a backup battery system with a hybrid network, where you can store the energy, maybe the solar energy, and you use it during a power failure. So even a further power failure, then you can switch on the generator, whereas this cost is drastically high. So important stuff with the solar PV installation is the key thing is the panel direction. So ideally, we call it has to be south facing. It has to be actually the latitude degrees of the location. So depending on the location also it will change. So 7 is something, I think our latitudes vary from 5 to 7 if I'm not mistaken. So 7 is something for the northern part and 5 is something for the southern part of the country. But although we say critical, the losses are not that much compared to in other directions as well. So in Colombo, east will have a bigger loss, but west will have a less loss. North is of course bit of a loss. So if you have multiple angles in the panel, installation could be a bit difficult because you can't connect them to a single inverter. You can single string. So you have to use multiple strings and maybe with optimizers to ensure that they all come into the same voltage generation. So panel angle and panel location is key to actually solar PV installation, unlike solar hot water. Solar hot water is okay to install because it is absorbing heat. The other key is inverter efficiency, but generally all the inverters now have 98% plus efficiency. Even some go up to 90, 97 is the minimum, 99 also. The other key thing is this is what you call the metering system. What is the metering system that you have to use? This is of course a very old brochure. The rates are revised now. There are 3 mechanisms which you can export to the grid. Okay, we call it net metering, net accounting, and net plus. So these will depend on your different requirement, but I don't know whether net plus is worthwhile now with the current tariffs, because the tariffs are lower and your consumption, your energy rates are high. So net metering is where they actually take the net value of the import and the export. So net metering is ideal if you are giving only part of the part of your consumption. Say you are consuming 400 units, but you are exporting only 100. Then ideal thing is to go into net metering, where they will take 400 minus 100. So your consumption is 300. Then only that 300 get into the bill calculation. So if you take, so then you are eliminating the highest tariff content. So now it has gone up to 89 rupees. So there is a big jump between less than 180 to 180 above. So there 30 rupees jump. So then you can reduce the high energy rate consumptions. So, but if you have a larger roof, and if you can expand your system, or if your consumption varies depending on the day, depending on the months, because some months you must be using more, or some months you may be using less, then you can actually go for a net accounting, where you actually get paid from CEB for the additional export, which means your export is higher. So they say your consumption is 400, but you're generating 600. So your entire 400 is negated, and so it's plus 400 and minus 400, then you have a 200 excess. So this 200 you actually get paid. I think the present rate is 37 or something for the generation, which CEB will pay you. So that is a very attractive system if you have a large roof and if you can afford to install the invest on a large PV system. Or if you have less consumptions and high consumption months, then you can actually carry forward. Carry forward can be in net metering as well in terms of kilowatt hours. They carry forward for about a year. But net accounting, when you have low months, then you also you get paid for the low consuming months for the extra generation. But when you have high consumption months, then you can actually zero your high consumption. So depending on your situation, you actually use net accounting or net metering. Net plus was very popular sometime back with industrial, where the energy rates were lower, which was something like 11 those days, and you get paid 15 for your energy generation. So what you do is, without taking at 11, you actually export the entire thing. So they will have a separate meter for the entire energy generation and take it out from your premises, and you get paid for that amount. But ultimately, the same energy is going to come inside your installation at 11 rupees. So net plus was actually in that context. But recently, there is also a net plus plus, which is a new scheme where you can, because all these systems, 1, 2, 3, you are limited with your contract demand. If you remember in the CEB bill, there is a contract demand amount specified, this number of kVA, that is the maximum demand you can request, you can go for, where your breaker is sized to that. So in all these cases, you are limited to that contract demand. So you can't install a larger system than that. But in net plus plus, you can actually install a larger system and export the entire thing to the grid. So those are the key energy schemes which are available, and which can be accounted to. So they will go for a 20-year 20-year skill and any 20-year agreement which you can sign with the CEB. But unfortunately, whoever signed years back are still at this rate. They cannot change the rate until 20 years. So whoever is signing now can actually go for the new rates. I think I had the new rates somewhere. Yeah, so these are the new rates. Revised tariff effective from 22 November. Rooftop. The other key important thing is CEB is particular on the installation. It has to be rooftop. It has to be on the top of a roof or top of a building. It has to be on the roof level. If you're installing on ground, they mention it as a separate system. What is the reason? Any ideas? CEB, as you might have also heard, so it's a 20-year agreement. So you cannot change for during the 20 years. Net plus and net plus plus schemes. Yeah. So you must have also heard there had been even court cases where CEB is reluctant to give approval for solar PV systems. What are the reasons? ඇයි CEB කැමති නැත්තේ solar වලට?
First thing that generation is coming in the off-peak time.
Yeah.
So there is no much effect to
හරි.
But the thing is, it is a hypothetical thing. But always we are getting the coal power thing at the rate of that in the same time. But hypothetically, they are telling that only daytime the generation is occur. So it is no much effect to the peak demand.
ඒකදී අපේ වැරද්ද නෙමෙයි නේ ඊරේ වැරද්ද. ඊරේ ඉතින් දවල්ට විතරයි නේ වැඩ කරන්නේ. අපි මොනවා කරන්නේ? රැට තිබුණොත් රැටත් හම්බ වෙනවා. What is the average price of production Sri Lanka energy electricity? මේක මොකක්ද? What is the difference in this one? So average energy production costs, what I heard last was 21 something, rupees 21. දැන් මේක කීයද?
More than 30, 35.
Oh, 34. There were 21 average production cost එකක් තියෙද්දි 34 වලට ගන්න එක පාඩුයි ඉතින්. So that's why this is specifically mentioned at rooftop solar installation. So they are limited to rooftop, whereas this is the other. This is any NCRE, non-conventional renewable energy. Where it's Venus. So CEB as an entity, is losing from rooftop solar installations. But on a national perspective, we are moving into renewable gradually. So because CEB's incorrect decisions, we are still running at a cost of 21 rupees, which ideally should come down to about 10, 12. Even with when the coal power plant came in, it was giving at 10, but I don't know what is the current price now. So only from the hydro where the O&M costs are very low, where we are saving something. So relatively, that's why CEB is a bit reluctant with this solar installation, because as an entity, they're actually losing. And if you see the tariff schemes also, so if you take the less than less than 30 එකට තමයි 12 වලට දීලා තියෙන්නේ. So they are giving at a loss for these consumers. So they have to actually gain that from the other consumers. So now they may not gain from the 180 plus, because naturally the 180 plus consumers will move to the solar option. නැක් අරන් හරි solar දායි ඒ කට්ටිය. So it is a situation where CEB cannot earn much. හරි නේද? Any questions? Anything you want to discuss? අපි සාමාන්‍යයෙන් මෙච්චර ඉන්නවද ක්ලාස් එකේ වෙනදට?
B1 කට්ටිය ජොයින් වුණා සර්.
right. අපිට වෙලා තියෙනවද මේ papers දෙකක් තියෙනවා නිකන් roughly එකක් හරි කරමුද? මම හිතන්නේ B1 කට්ටිය ඒක බලාපොරොත්තු වෙන දන්නේ නැහැ. මේ hotel management papers දෙකක් වගේ තියෙනවා. similar වෙයි ඔයගලන්ගේ එකත්.
කරමු සර්.
Shall we quickly discuss?
Yes.
Yeah, so this is 2019. මේ ප්‍රශ්න තමයි වැඩි සලකන්න එපා, but similar thing will apply for even other buildings. මීට වැඩිය ටිකක් advanced වෙයි ඔයගලන්ගේ questions because this is particularly for hotel management students. Name three key energy sources of a typical hotel in Sri Lanka, significantly affecting the operational cost of the facility. Key energy sources කිව්වම
Electricity, gas, diesel.
ඔව් ඒ වගේ තුනක් වගේ ලියන්න. And mention whether they are renewable or non-renewable. What is renewable and non-renewable?
It's all biomass, renewable.
Yeah. Solar will be renewable and biomass will be renewable if they are using. So if you have mentioned any of those, and even electricity is both partly renewable, partly non-renewable, because we have a bit of hydro contribution of about 30% and other renewable sources. So electricity is partly renewable and partly non-renewable. So that was the key thing to answer. But others like diesel, LP gas, everything is non-renewable. Okay. So renewable is something that is what do you call it? Replenished or replaced within an accepted period or within a short while, which is not depreciated with time. Whereas like sunlight, wind, solar PV, solar thermal, daylight, all that will come into renewable. Whereas non-renewable will be which is depreciating with time, like gas, diesel, LPG, petrol, etc., where you're losing with the usage. So the number of years or the time to actually reproduce is quite longer than the lifetime of consumption. Okay. Following are some utilities used in hotel sector. Select energy sources out of it and mention what type of energy it is. මේ ගොඩක් අය වරද්දගත්ත ප්‍රශ්නයක්. So utilities දීලා තියෙන්නේ. You have to select whether they are energy sources or not. Charcoal used in barbecue burner. පොල් කටු අඟුරු.
Energy.
Barbecue. Energy the?
Energy.
Yes, energy, because you are burning them and you are taking the heat output out of it.
Non-renewable.
Yeah, and it is renewable. Yeah, why renewable? because it's charcoal and it is coconut,
Shell.
what do you call it? Husk, whatever.
No shell.
Coconut shell, yes, coconut shell. And it is in no time, it is actually replaced. Water supply from water board,
Not energy.
not energy. Anitya, in line neda? Okay, so water supply is not energy.
Excuse me, sir.
Yo,
Sir, එතන දැන් pumping වලට එහෙම energy ඕන වෙනවනේ.
අන්න එතන තමයි පටලු ගන්න.
Energy source එකක්
නෑ,
නෙමෙයි.
ඒක අහන්නේ energy source එකක්ද කියලා මේක.
Energy ගන්න තැනක් නෙමෙයි අපි energy වියදම් කරන තැනනේ.
අහන්නේ මේ utilities වලට energy sources ද කියලා.
හරි sir.
මේකේ ප්‍රෙෂර් එකෙන් මොකක් හරි වට ටර්බයින් එක කරකවනවා නම් අන්න පොඩ්ඩක් ප්‍රශ්නයක් තියෙනවා. Okay, but generally it is not. Okay. Biogas produced from carbonic waste.
Energy.
Biogas plant එකක් තියෙනවා. ඔය waste ඔක්කොම මේකට dump කරනවා. You are getting a gas out of it, which is methane නේද? And you can burn it in a cooker. So that is a energy source. And that is what energy?
Renewable.
Renewable energy. Yes. Okay. Wax used for preheating under buffet dishes. අර warm තියාගන්න ඔය පොඩි එකක් තියෙන. ඒකට wax දාන්නේ ගොඩක් වෙලාවට. wax කියන්නේ ඉටි දාන්න. energy ද නැද්ද?
Not energy.
It's energy. Heat engine.
නෑ, not energy කිව්වේ. ඒවා හිතුවේ not energy කියලා.
Equivalence energy එකක්.
ඈ?
Equivalent energy.
පිටිපන්දම් පත්තු කරන්න
ඉටි පන්දන් ඉතින් ඉටිත් එන්නේ කොහොමත් රිෆයිනරි එකේ යටම ඒක බර්න් කරනවනේ. කාබන් හයිඩ්‍රජන් මික්ස් එකක්. නේද?
Okay.
අපි යූස් කරන්න ගන්නෙත් heating වල preheat වලටනේ.
මොන හරි ඒක බර්න් වෙලා දැන් ඒක අවුට් එකේ ඒක නෑනේ දැන්. අපි වතුර ගත්තොත් වොටර් බෝඩ් එකේ වතුර ඉතින් වතුර හැටියටම එනවනේ. ඒක බර්න් වෙලා ඒකේ ප්‍රොපර්ටිස් මෙයා වෙනස් වෙලා නේද? It's no more carbon hydrogen mix. And you're taking the heat out of it. ඒ heat එකනේ වා use කරන්නේ. equation එකට හරියනවානේ. Fuel plus oxygen, CO2, H2O plus energy.
සර් අතන වෝටර් බෝඩ් එකේ මේ වෝටර් වලට මෙතන දාන්න ඒතර ෆ්‍රී එනර්ජි කියලාද?
නෑ ඒක නිකන් not a energy source විතරයි. If select energy sources out of it and mention what type of energy it is. එතකොට energy sources ටික select කරලා ඒ ටික මොන energy ද කියලා දාන්න. energy නෙමෙයි නම් ඉතින් එතනින් ඒක ඉවරයි. Not energy. හරිද? ඊළඟට daylight sunlight used in BOH areas through windows.
So wax වල එතකොට energy type එකට දාන්නේ මොකක්ද?
wax වල මොකක්ද energy type එක?
non renewable.
No, non renewable නැත්නම් primary. ඒක fuel එකක් නේ. ඩීසල් පෙට්‍රල් වගේ. එහෙනම් අපි කෙලින්ම ග්‍රවුන්ඩ් එකෙන් අරගෙන ෆස්ට් ට්‍රීට්මන්ට් එකකින් යූස් කරනවා. රිෆයිනරි එකකින්. හරිද? කියන්න ඔයගොල්ලන්ට හිතෙන්නේ ඒවා. Okay. Next, daylight sunlight used in BOH areas, back of the house areas කියන එක. Through windows.
energy.
Energy.
renewable energy.
Renewable energy. Oh, like a free energy. අපි මොකොත් major investment එක ගන්න නැහැ. Yeah, renewable energy is correct. Composting of bio waste. Bio waste වලින් compost හදනවා.
It's not energy.
Not energy. අනිත් අය?
not energy.
Not energy. හරි නේද? clear නේ? වෙනසක් නැහැනේ වායවා. ගිනි තියලා heat එකක් හරි මුකුත් අරන් නැහැ. So it's not energy. Lubricants used in machinery.
not energy.
Not energy. Purpose එක වෙන එකක් නේ. Friction අඩු කරන එක හරි එහෙම purpose එකක් තියෙනවා. So you are not burning them. Clear ද? මොනවාරි තියනවද?
සර් commercial energy විදියට එතකොට මොනවද ගන්නෙ?
commercial energy වෙන්නේ electricity. මොකද electricity කෙලින්ම ගන්න නෑනේ අපිට. මොකක් හරි අපි convert කරලා තමයි ගන්න. එක්කෝ ඩීසල් පුච්චලා generator එකකින් electricity හදනවා නැත්නම් potential energy එකක් convert කරනවා electricity වලට. electricity කියලා එකක් නෑ ගන්න මේකේ. naturally. ඒකයි commercial energy වෙන්නේ.
දැන් මේ ප්‍රශ්නේ ජස්ටිෆිකේෂන් එකක් එක්ක ලියන්න කිව්වම ගොඩක් විස්තර කරන්න ඕනේද?
නෑ නෑ අයියෝ පෙළ දෙකක් ලියන්න තු දිගට ලියන්න එපා. පුළුවන් නම් ඔක්කොම point form වලින් ලියන්න. මම අර keywords ටික තමයි කියවන්නේ. පෙළ දෙකක් ලියුවොත් ඇති. හරිද? What are the units of measurement commonly used for different energy sources? ඉවම් පොඩ්ඩක් broad වැඩි topic එක මේ energy sources වල අපි කියමු electricity වල what is the unit of measurement? Common unit of measurement? මොනවද in mind?
කිලෝවොට්
Kilowatt hours. Oh. මේවා liquid fuel diesel petrol ඒ වගේව
Liters.
liters. එතකොට gas ඒවා LPG natural
Kilo.
gas biogas
kilogram.
කිලෝ
yes kilogram උත් හරි cubic meters උත් හරි එතකොට solid fuel coal biomass ඒවා
Meter cubes are
kilogram.
kilogram.
kilogram බරනේ බලන්න
Barbara.
හරි different energy sources are measured in different units.
Electricity kWh.
Oh. So different energy sources are measured in different units during purchasing. Give examples and explain how those can be converted to a single unit to calculate the energy input. මේක අර අපි අර Excel එකේ කරේ මොකෙන්ද අපි
Calorific
වැඩි
value.
කරන්නේ? ඔව් calorific value එකෙන් වැඩි කරලා
Joules වලට
arrive
convert.
at the joules. So okay, then you can add them together and find the total energy input of a facility. හරි. Question 2 electricity පැත්තට බාරය answer with regard to electricity sector for hotels in Sri Lanka. What is the difference between demand for energy and energy consumption? Describe with examples. The demand.
ඩිමාන්ඩ් එක කියන්නේ ඇවරේජ් amount එක.
Demand එක point මේකක්. ඒ කියන්නේ for a at a point of time what was your kilowatt of power demand කියන්නේ. So energy is what you consume during the entire time period, which is measured in kilowatt hours. But demand is measured in kilowatt or kVA, both fall into the same. It is a rate value or particular value at a point of time. Electricity in hotels in Sri Lanka is provided under special tariff. Again, may discuss its components and with reasons for such charges. You may use the attached tariff sheet as a guideline. So hotels will fall in this category. So definitely it's a special tariff. So hotel and industrial, they are almost the same. It's like the same, yeah. So they are actually charge less to encourage the industry basically. So, and they have energy charge divided into peak, off-peak and day. So the rates are different. Okay. Plus you have a demand charge, plus the fixed charge. Okay. Or rate 2 and rate 3. So rate 2 is from 42 kVA going up to 1000, and this is for medium voltage supply, rate 3. So key thing is why less is to encourage the industry, and it is divided into time of day with the rate 2 and rate 3, and also there is a demand charge. So those are the key components of the bill calculation or the tariff calculation. So ඒ ටික summarize කරලා ලියන්න. ගොඩක් එපා. අපේ 3-4කින් ලියන්න පුළුවන් නම් ලියන්න නැතු. Not more than half a page. Readings ටිකක් තියෙනවා, so you have to calculate the bill. කොහොමද bill එක හදන්නේ? How do you calculate the bill?
meter reading
Oh, meter reading එක වෙනස
difference
ගන්න
කරන්න.
නේ. Oh, total bill amount. into කීයද? day එක මේක කොයි එකටද වැටෙන්නේ කියලා පොඩ්ඩක් බලා ගන්න වෙනවා. කොහොමද බලාගන්නේ? rate 1 ද 2 ද 3 ද වැටෙන්නේ කියලා. කොහොමද බලන්නේ? Is this rate 1, 2 or 3?
maximum demand එක
No, maximum demand එක. So this is rate
350 කියන්නේ
මේක 1000 වෙනකම් 42 to 1000.
1000
නැත්නම් වට assumption එකක් දාන්න පුළුවන්. මේක rate 2 මේක rate 2 හරි 3 තමයි වෙන්නේ. 1 කොහොමදත් වෙන්නේ නැහැ. 3 වෙනවා අඩුයි. මොකද 3 කියන්නේ 1000ට වැඩි ඒවා නිසා. So you can write an assumption or you can say rate 2 කියලා.
42
So
kVA කියලා කියන්නේ ඒ කියන්නේ මෙතන
arithmetic.
මේ maximum demand එකේ 350 කිව්වාම kVA නේ 350 වෙන්නේ.
ඔව්. ඔව්.
එතකොට අතන 42 kVA නේ තියෙන්නේ සර්.
ඔව්.
ඒතර 42000ක නම් යන්න පුළුවන් ඒක. RC
නෑ. ඉතින් මේකත් KVA නේ. maximum demand දෙන්නේ KVA එකේ.
kVA
VA එකෙන් නෙමෙයි. හරිද?
ඔය එතකොට 2 ද 3 ද යන්නේ සර්. එතන
Ideally 2
තමයි
ideally 2 3 එකේ වරදක් නෑ. 3 ඉතින් වෙන්න පොඩක් unlikely.
right මෙතන 42කට වැඩි කියන එක තියෙන්නේ නේද 42 ඉඳලා
42කට වැඩි.
1100
contract demand එක 42කට වඩා වැඩි.
උඩ එක 42කට වඩා අඩුයි.
ඔව්.
කියන්නේ kVA 42කට වඩා අඩුවෙන් යූස් කරන ඒවා. මෙතන 42කට වඩා වැඩියෙන් ඒතර 11 kV
මේක supply voltage එකෙන් දීලා තියෙන්නේ. මේක දෙන්නේ 1000ට උඩ ඒවා. 1000 කියන එක පොඩ ඔළුවේ තියාගන්න වෙනවා. 1000ට වැඩිව තමයි මෙයාගේ රේන්ජ් එකේ ඉන්නේ.
මේ තියෙන අර ට්‍රාන්ස්ෆෝමර් එක අපි දාන වෙනස.
ඔව්. 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 rate 3 එක
ට්‍රාන්ස්ෆෝමර් belongs to property.
property ඔව්.
එතකොට contract demand කියලා අර මේ bill එකේ ඉන්නේ 1000 contract demand කියලා. එතකොට එන්නේ rate 3ද?
Rate 2
contract demand එක මේ මෙතන තියෙන rate 2 එකේ contract demand එක 42 kVA වලට වඩා අඩුයි.
ඔව්.
rate 2 එකේ rate 3 එකේ 1000 වලට වඩා වැඩි. එතකොට bill එකේ එනවනම් contract demand එක 1000 කියලා 3 වලද යන්නේ එතකොට?
bill එකේ 1000 එනවා කියන්නේ rate 2ම තමයි. 1000ට වැඩි ඒවා තමයි rate 3. ඒ කියන්නේ ඒගොල්ලෝ 1000ට වඩා ලොකු ට්‍රාන්ස්ෆෝමරයක් තියන්න වෙනවා නම් ඒගොල්ලෝ තියන්නේ නැහැ. CB එකෙන් තියන්නේ නැහැ. සාමාන්‍ය ප්‍රැක්ටිස් එක.
තොරස මෙතන වැඩියම අපි මේ ඔය කන්ට්‍රැක්ට් ඩිමාන්ඩ් එක සලකන්නේ අතන KVA මේ රේට් එක යන ප්‍රමාණයත් එක්කද?
එතන දැන් ඔයගේ contract demand එක ඔයා හිතන්නකෝ 500යි කියලා ඔයා ඉල්ලලා තියෙනවා කියලා.
අපේ කන්ට්‍රැක්ට් ඩිමාන්ඩ් එක 1000 කියලා එනවා.
ආ,
KVA
1000
charge
කියලා.
KVA units ගාන 450 වගේ එනවා.
ඔව්. ඉතින් ඒ වගේම සිටුේෂන් එකක් තමයි. ඒ කියන්නේ 1000 ට්‍රාන්ස්ෆෝර්ම එකක් තියෙන්නේ. ඒවා යූස් කරන්නේ 350යි 1000ට වඩා අඩුයිනේ ඩිමාන්ඩ් එක
ඔව්.
මැක්සිමම් ඩිමාන්ඩ් එක අනිවාර්යෙන්. ඊට
ඔව්.
වඩා වැඩි වෙන්න බෑනේ. මොකද ඊට වඩා වැඩි වුණොත් ට්‍රිප් වෙනවා.
ට්‍රිප් වෙනවා.
ඔව්. එතකොට 1000 කියන්නේ අනිවාර්යෙන් CB එකෙන් තියලා තියෙන්න ඕන ට්‍රාන්ස්ෆෝර්ම.
ආ.
ඒක රේට් 2 එකෙන් යන්නේ. 1000ට වඩා වැඩියෙන් ඔයා ඉල්ලුවොත් එතකොට ඔයාට කියනවා අපි දෙන්නේ 11 කිලෝ වෝල්ට් සප්ලයි එකක්. ඔයා ට්‍රාන්ස්ෆෝමරේ තියාගන්න කියලා. එතකොට ඒගොල්ලෝ
ආ.
මීටර් කරන්නේ HT සයිඩ් එකේ, MV සයිඩ් එකේ.
ආ.
හරිද? මේක හදන්න ඕනේද? පුළුවන්ද? ඩිෆරන්ස් ටික අරගෙන රේට් සෙලින් වැඩි කරන්න ප්ලස් what?
ෆික්ස් කොස්ට් එක.
ෆික්ස් කොස්ට් ප්ලස්
KV charge එක.
KV charge. හරිනේ. Okay. Answer with regard to ISO 50001. මෙතන අහන්නේ අර ඩයග්‍රෑම් එක. මේ ඩයග්‍රෑම් එක පොඩ්ඩක් ඔළුවේ තියෙන්න ඕන ISO 50001. කොහෙද ඔය කැලේ ටික තියෙන්නේ කියලා. එන්න මේක. මේක key ISO ට. So you start with make commitment, assess performance, set goals, make a continuous improvement, action plan and implement, evaluate, recognize. එතකොට ඒ flow diagram එක ඇඳෙන්න ඕනේ. Describe the following terminology commonly used in energy management. Energy policy, energy manager, energy auditor. Consisting of the objectives and the long-term and the short-term goals with regard to energy. Giving the top management commitment or signed by the top management. මේ වගේ points තුනක් තිබුණොත් ඇති. So energy manager is the key person in the energy team who is guiding the energy management process, who will set goals, track progress, and will be promoting the energy management. Then energy auditor ගැන specifically ලියවෙලා නැහැ. So energy auditor can be a third person conducting an audit of the system and giving the potential improvement. So energy auditor can be an external person or a person from the company who is a technically capable person to look at saving measure and identify the potential improvements that you can develop. මේ ටික සාමාන්‍ය points 3ක් 4ක් වගේ ලියන්න ඇති වැඩි ලියන්න එපා. What are ENPIs and give examples of some used in the hotel sector. What do you mean ENPIs? Yeah. So ENPIs will be things like this, your performance indicators, energy performance indicators, which will indicate how much of consuming per person. Examples be per guest night, per meal, per day, or whatever. Make 25-room hotel plan to be developed in Nuwara. නුවරඑළිය කියලා මගේ Word document එකේ නා රතු පාටට තියෙනවා. ඒක ප්‍රශ්න පත්‍රයේ තියෙන්නේ නැති වෙයි. So particularly Nuwara is a different scenario. He is considering the following options to produce hot water for guest rooms.
Recording stopped. Recording in progress.
Sorry, මාව disconnect වුණා පොඩ්ඩක්. ඇහෙනවනේ මාව?
ඔව් සර්.
Okay, so we were here. So compare and contrast between the proposed option in terms of initial cost, availability of the energy source, logistic of the energy source, operating cost, maintenance.
Screen sharing එක දෙන්න.
Sorry. මේක assignment එකකට කරනවද තුන්වෙනි assignment එකට?
Ah, sir.
The presentation එකේ අන්තිමට add කරන්න. Okay, electric geysers දැම්මොත්. What is the initial cost නිකන් අඩුද වැඩිද average ද කියලා relatively compared to the others මේ යට තියෙන technologies වලට compare කරලා whether the cost is more or less
ඉන්ටර්මීඩියට් නේද?
අඩුයි.
LP gas heating and biomass is high.
අඩු තමයිනේ medium වත් වෙන්නේ මේක lowest වෙයින් geysers will be lowest to install initial cost availability of the energy source
High.
available because electricity available not a problem logistics of the energy source
No
no
issue.
issue නේ it's delivered to home ගිහිල්ලා බැරල් එකේ දාගෙන එන්න මුකුත් නැහැනේ okay operating cost
Minimum.
operating cost
හයි.
highest
So highest energy use කරනවා නේද?
oh electricity නේ so highest
Maintenance
maintenance
lowest. Maintenance lowest.
maintenance lowest දුනියන් ටේබල් එකක් වගේ දාලා එක එක ටෙක්නොලොජි එකක පැත්තක then උඩ මේ යට මේක එක පැත්තක දාලා මේක අනිත් පැත්තේ දාලා so ඒ ටේබල් එක ඇතුලේ you can write that's more than enough so one sentence is enough okay solar hot water initial cost
At low.
High.
Solar hot water කොච්චර ගානක් නැහැ. Geyser එකට වඩා වැඩි.
availability of the energy source
low
ඒක average හැබැයිනේ.
medium.
නොරෙලියට සමහර වෙලාවට ප්‍රශ්න අඩු විතරක්.
නුවරඑළියට ලෝ නේද?
Recording stopped. Recording in progress.
hello hari so solar hot water availability of the energy source
නුවරඑළියට ලෝ.
low ne low because no really logistics of the energy source logistic issues නෑනේ නේ solar
no
it is available. Operating cost
Low.
maintenance
Low compared to other two.
oh compared to others තමයි compare and contrast hari LP gas heating initial cost
High.
initial cost oh high hari average මොකද biomass තියෙන හින්දා හතරට comparatively are average availability of the energy source
Available. But
Logis-
difficult. Logistic difficult.
logistics difficult operating cost
minimum
Compared to biomass and solar hot water, high.
high එතන average කියන්න පුළුවන් නේ operating
Correct.
cost මේ හතරෙන්
Electricity වලට වඩා අඩුයි.
electricity වලට වඩා අඩුයි. එහෙනම් average කියන්න පුළුවන්. Maintenance
මේන්ටනන්ස් කොස්ට් එකකුත් නැහැ.
maintenance cost එකක් නෑනේ. Yeah. හරි. Biomass initial cost
හරි.
high.
එනර්ජි
Availability
සෝස් එක ටිකක් ඩිෆිකල්ට් මොකද ඩ්‍රයි
difficult. ඔව්.
බයෝමාස් හොයාගන්න
ඔව්.
වෙනවා.
ඔව්. energy source එක difficult. Logistics
Logistics is
difficult. Operating cost
less.
yeah lowest.
Maintenance
Maintenance
high.
highest. 25 room එකකට මොකක්ද recommend කරන්නේ ඔයගොල්ලෝ? ඒකත් ලියන්න ඕනේ. සාධාරණ හේතු එක්ක. මං කියන එකම ලියන්න ඕනේ. ඔයාලට points කියන්න පුළුවන් නම් මේ හේතු හින්දා මම මේ ටෙක්නොලොජි එක recommend කරනවා කියලා ප්‍රශ්නයක් නැහැ.
Electric greases තමයි මගේ choice එක.
එහෙමද?
Yes.
gas ඔව්. මම gas වලට පොඩ්ඩක් නැඹුරුයි. electric geyser සාමාන්‍යයෙන් 10කට වඩා අඩු නම් නේද? centralize එක gas system එකක් තිබ්බනම් room 25ටම දෙන්න පුළුවන්. අනිත් අය හරිනේ ඒකෙන්. So we'll move on. Yeah, so this is the last one. A banquet hall of a large hotel consists of 5 large chandeliers hanging from the ceiling. Each chandelier consists of 12 numbers of 25-watt filament candle lights. During the last meeting of the energy team, the members proposed these to be replaced with LED filament bulbs of 3 watt. Each bulb will cost rupees 500 in the market. Calculate the following. Present energy consumption per month with assumptions stated. මොකද්ද මෙතන නැත්තේ?
Operating hours.
ඔව් operating
Time of
hours.
operation.
ඔව්. ඒකට operating hours assume කරන්න. 4 hours per day hari 8 hours per day hari මොකක් හරි. Okay. මගේ ප්‍රශ්න copy කරන්න බෑ. එක එක්කෙනා එක එක assumptions දාලා ලියන්නේ. මේ එතකොට කොහොමද හදන්නේ? Present energy consumption. ඒ කියන්නේ before replacement.
5 into 12 into 25 into time.
ඔව්. Into time into days.
Yes.
days උත් assumption එකක් වෙන්න පුළුවන්. ඊට පස්සේ අන්තිමට එතකොට මොකක්ද දෙන මොනවයින් දෙන්නේ? මොන එකක වලින් දෙන්නේ?
KWH වලට ගන්න පුළුවන්. 1000 වලට.
KWH වලට ගන්න 1000 වලින් බෙදන්න ඕනේ. Yeah? You are getting watt hours. Present energy cost per month with assumptions.
unit rate ටිකක් දාලා
රේට් එකක් දාලා හදන්න වෙනවා. ඔව්. එතකොට ඔයාලට හිතන්න පුළුවන් දවල් පත් වෙලා තියෙන බැංකුවට කියලා හරි රේකෝ රෑ පත් වෙලා තියෙන එකක් හරි කියලා හිතලා you can take a rate.
එක රේට් එකයි නේද ගන්න එතකොට?
එක රේට් එකක් ගන්න. assume average cost කියලා දාලා
නෑ අපිට ඕන නම් ටයිම් එකක් දාලා ලස්සනට කරන්න පුළුවන්. අපි 10 ඉඳලා රෑ 10 වෙනකම් බැංකුවෙට් එක දාන්න කරලා තියෙනවා කියලා.
නුවන් කරන්න කියනවනේ කරන්නත් මොන හරි තියෙන්නේ හරි okay. Estimate energy saving and cost saving. Energy saving හදන්න ඊට ඉස්සෙල්ලා මොකක්ද හදාගන්න වෙන්නේ?
අලුත් ප්‍රොපෝස්ඩ් එකේ කතර විදිහටම
ඔව්
හදාගන්න.
ප්‍රොපෝස් එකේ තර විදිහට හදන්න වෙනවා. එතකොට 3 දාලා හදලා මේ එනර්ජි එකෙන් අර එනර්ජි එක අඩු කරන්න වෙනවා. අඩු කරලා රේට් එකෙන් වැඩි කරාම you get the cost. හරිද? ඉන්වෙස්ට්මන්ට් එක ඉෂුව එකක් නැහැ නේ 500 කියලා දීලා තියෙනවා. number of
එතන සර්
light
කොස් සේවින් එක හදනකොට අර 500 ටිකට යන ගාන වැඩි කරලා ඒක අඩු කරන්න ඕනේ නැද්ද?
cost
එනර්ජි
saving
සේවින්
හදනකොට
අපි
energy cost saving
එනර්ජි කොස්ට් එක හරි හරි.
ඔව් අත අරක ඉන්වෙස්ට්මන්ට් එක. ඒකට 500න් ඔයා number of bulbs වලින් වැඩි කරොත් ඔයාට ඉන්වෙස්ට්මන්ට් එක එනවා. required investment. Then return on investment will be investment බෙදීම cost saving.
කොස් සේවින්.
cost saving per month ද කියලා බලන්න. එතකොට month වලින් එයි payback එක.
ඒක.
return on investment. හරිද? පොඩිනේ ඔබ ගානක්. පේපර් එකකුත් තියෙනවා වැඩි වෙනසක් නෑ මම මේ දෙකම දාන්නම් group එකට මේ නුවන්ට දාන්නම් නුවන් ෂෙයා කරන්න මේ
හරි සමන්ද.
එකත් බලන්න මොකද කරන්න පුළුවන් කියලා අපි ඒතකොට තව දවසක් ගන්නවද මේවා එක්සැම් එකට පිටු වෙලා
සර් ඉක්වේ software එක ගැන කරන්නේ නැද්ද සර්?
පා මම දන්නෙත් නෑ හරියට ඔත් ඉගෙන ගන්න හදනවා එනර්ජි මොඩලින් කරන්න නේ ඒක කවුරු හරි කව වෙන්නේ නැද්ද ඔයගලන්ට
නෑ සර්.
මොඩලින් එන්නේ නැද්ද
නෑ සර්.
මොඩලින් තිබ්බා මම අර කලින් කරපු බැච් එකට මට නෙමෙයි තව කෙනෙක්ට කරන්න. ඒක 4th ඔයගොල්ලෝ 3rd year ද ඉන්නේ මේ?
third year සර්.
ඔව් සර්. final year.
තමයි 4th year එක වෙන්නේ.
ඒක 4th year එකේ. 4th year එකේ තිබ්බා එනර්ජි මොඩලින් කියලා එකක්. ඊක්වෙස්ට් එකේ තියෙනවා පොඩි පොඩි අවුල් යන තැන් ටිකක් අර එනර්ජි දාද්දි. ක්ලයිමට් ෆයිල් එකක් හොයාගන්න වෙනවා හැමෝම රත්මලාට තමයි දාන්න වෙන්නේ එකක්. එයා කන්ඩිෂනින් මේවා ටික හදාගන්න.
හරි.
කරලා CAD එක වට කෙලින්ම ඉම්පෝට් කරන්න පුළුවන් මේකට. ඉම්පෝට් කරලා ඒකට බිල්ඩ් කරන්න ඕන. තට්ටු ටික. කරලා glass brick ඒවා properties ටික දෙන්න වෙනවා. අනිත් loads ටික නම් ඔයා counseling එයා ගන්න. ඔයා number of lights ඒ ටික කියන්න පුළුවන් wattage එක. වල මම තාම ඉගෙන ගන්නවා equest. මේ මට එන එක්සෑම් ළඟ වෙලා දවසක් කියන්න මේකට. මේ ඉම්පෝටන්ට් අසයින්මන්ට් එකක් හරි යවන්න. මම ඒ නම්බර ටික දාලා යවනවා අරකට සඳුදා. මේ eligibility requirement එකට. හරි. shall we stop at that point then? මේ දෙක මම දාන්නනේ. ඒ පේපර් එක ලේසියිනේ නේ. ඊට ටිකක් අමාරුවට හදමු.
ඒකත් අමාරුයි සර්. ඊට වැඩිය නම් අමාරු කරන්න එපා.
නුවන්ට ලේසිලු යාට තව වැඩිපුර එනර්ජි තව ප්‍රයිස් දාලා අලුතෙන් හදන්න යන්නේ ගන්න.
මේ දවස්වල එනර්ජි සීන් එකේ ඉන්නේ ඒක නිසා. එන සීන් එකේ ඉන්න එනර්ජි වල.
හරි හරි ඕකේ ඕකේ. මම හදන්න මොඩල් පේපර් එකක් හදන්න. ඕකේ.
දැන් නෝට්ස් ටික පොඩ්ඩක් දාන්න Google Drive
ආ
එකට.
රයිට් ඕකේ. මම අප්ලෝඩ් කරනවා. හරි thank you man.
Okay, thank you very much sir.
Okay sir,
Thank
thank
you,
you.
sir. Thank you, sir.
Thank you.
Record.